before I started what I'm doing now, I led the first American ascent of a mountain called Annapurna, which has the highest fatality rate and is considered perhaps the most dangerous and difficult mountain in the world. It was the first American ascent with an all-women's team. And I have to say what I'm doing now is much harder and much more important. And every day I feel like I'm on Annapurna. And it's a very familiar feeling working with a great team of people. I hope some of you will join the team, and the ascent is to a healthier world. And it's kind of amazing what a voice science can have in changing policy. So let's see where we are with slides. Okay, so the green science.
Sorry, did you want to do
the movie?
Did I spend too much time? Do we want to see a little
from
the movie?
Sure. Or you know what? Let's.
We're gonna have a.
You know what? Let's do it partway through the slideshow since we didn't know anyway.
Okay.
Will that work? Okay. So you'll get to see a little preview of a movie later on. It probably fits there. Anyway, so the Green Science Policy Institute is basically PhD scientists, masters in public health, and we have learned that science can have a huge voice in public policy, and that unfortunately not as much science has in the past gone into policy decisions, and so that's our goal, to bring good science to policy and help educate scientists all over the world to do research that can have a policy impact and then actually use their science to change policy. So the problem, and I think everyone in this room knows it, I often start by asking an audience if there's a chemical in your shampoo or your toothpaste, do you think someone's making sure it's safe for your health? And most people think so, but I won't even ask the question here. We know about the TSCA problem, and we know that the U.S. Toxic Substances Control Act is the only law in the United States that controls chemicals before they go out in the environment. Once they're out there, there's a Clean Air Act, a Clean Water Act, but this regulates them before they go out. And when it was passed in 1976, 62,000 chemicals were grandfathered, that they're okay. These include asbestos. Asbestos kills about 10,000 people a year in the United States. The EPA spent several years trying to regulate it. We're not successful. And they do not even try to regulate those 62,000 chemicals. Now, people say, wait, asbestos is regulated. We're not allowed to use it. Asbestos is regulated by lawsuits. So when people have a lot of exposure, they can get mesothelioma. The only thing that causes mesothelioma is asbestos, so it's pretty obvious. There are asbestos lawsuits, and everyone who wins an asbestos lawsuit dies of mesothelioma. That's not how we want to regulate chemicals in our country. Beyond the 62,000 grandfathered chemicals, there have been about 20,000 new chemicals. There's no requirement for any data. 85% of these chemicals have no health data, 67% have no data at all. So this is really the problem. There is not regulation. There's a lot of varied efforts for toxic chemical reform, and I'm not going to talk about them today because that could be a whole lecture. But I will tell you what a group of us came up with as a possible solution. So about a year ago, 20 people, a third were scientists, a third were NGOs, a third were from companies, and all of us had a passion for reducing toxics. We got together and we decided to say, what are the most harmful classes of chemicals? And why do you want to think about classes? Well, there's a real tendency when a chemical is banned, you want to keep industrial processes the same. So if a chemical is regulated, what's the replacement? The chemical cousin. And when that's regulated, it's another chemical cousin. And so maybe you want to just think about a whole class instead. So we decided to think about what classes had irrefutable evidence of harm for some or all of the members of the class, that those classes could be red flagged, and that people who are making decisions about chemicals could choose not to use a class. And I don't really believe in red lists or banning lists of chemicals, because when you ban a chemical, there's always the chemical cousin. But if you think about a whole class and say, we don't want a chemical in this class, then you can move to safer chemicals. So I'm a chemist, and I believe that through chemical education, this problem can be solved. And so here's the periodic table. Everybody loves the periodic table, right? And let's see, and I apologize, it's hard for me to point at both screens. Let's see that. So over here are the halogens, fluorine, chlorine, and bromine. And when these molecules are bonded to carbon, you have a very, very strong bond. It tends not to break very easily. So those molecules, when you have carbon bounded to fluorine, chlorine, or bromine, you have a very, very strong bond. These molecules tend to be persistent. There are no natural molecules in mammalian biochemistry with carbon bonded to fluorine, chlorine, or bromine, so our bodies don't really know how to deal with them. The ABC cassettes in our cell membranes that keep toxins out of our cells, they don't recognize those molecules, so they just go into our cells. The systems, the enzymatic systems that toss toxics out of our cells, they don't recognize those molecules, so they stay in our cells. And they're very strong bonds, so they last a long time. So just by the nature of the chemistry of these molecules, these are problematic classes of chemicals. So at our retreat, it was up in the Blue Mountains. We called it the Blue Mountain Retreat. I always like to have mountaineering and things. We went through many, many chemicals, and this is what we came up with. 6 classes. The first are the fluorinated chemicals, PFAS, PFOA, stain and water repellents. Then the chlorinated antimicrobials, triclosan and triclocarban. The flame retardants, brominated, chlorinated, and phosphate. And I'm going to be speaking about all these in some more detail today, particularly the flame retardants, which are my expertise. And then the endocrine disrupting plasticizers, BPA and phthalates. There's some organic solvents, benzene, methylene chloride, xylene, and then some metals, lead, mercury, chromium, cadmium, arsenic. All of these are chemicals that we know are harmful. There's no doubt about it. If we could reduce the use of these classes of chemicals in our products, we would all be healthier. So we don't have to do a lot of toxicology. We don't have to kill rats. We just have to educate the people who buy chemicals, who buy products, to avoid the use of these classes. And to me, it's not all, there's lots of other things, but this, when I show this to people, they say, yeah, that's half or 2/3 of the chemicals in our products that cause problems. And so instead of when you hear 80,000 chemicals that aren't tested, what can you do? It's so complicated. But I think 6 classes, the concept is a way that we can start to handle this 80,000 chemicals. So we, after our retreat, had a webinar series last fall. We promised people in 15 minutes you can basically learn the chemistry of a class, where it's used. And 1,500 people signed up for the series. Most retailers and manufacturers in the country, someone signed up. And we heard from companies, they said, oh my gosh, we had no idea we had triclosan in our products, and we're going to take them out. So just providing education can enable people to make better choices. And if any of you want to hear these, go to 6classes.org. And you can hear the six lectures, and there are actually 8 in the series. The 7th lecture is by Debbie Rayfield, who's the head of the Department of Toxic Substances in California, and her lecture is called, Is It Necessary? Because in many cases, when you know what these chemicals are they necessary? If you say to a mom, well, you can have a nice stain and water repellent carpet, but there's a fluorinated chemical that's going to end up in your baby for many years and cause harm. What's that mom going to do? What's she going to choose? But the mom doesn't know it. So the question, is it necessary, would actually, once you know that it may well be toxic, if you ask, is it necessary, if you balance that, maybe you just don't want to use these chemicals. And then the final lecture was green chemistry. Green chemistries have been around for about 20 years. Unfortunately, very little resources go into green chemistry because people want to keep their processes as similar as possible. So when deca ether is banned, the substitute is decaethane, and everything stays the same, and people do not invest in green chemistry. So we believe that thinking about the 6 classes, asking is it necessary, will lead to an investment in green chemistry and more green jobs. It's always about jobs. So, but I encourage you to check out 6classes.org for the simple chemistry lesson. And we got great feedback. The evaluations, people were all very happy that in 15 minutes they had learned new chemistry. We worked hard on those. Okay, so I'm going to go through briefly the first 3 classes. And this lecture was presented by Jennifer Field. It's not my expertise. I'm going to share part of Jennifer's lecture with you. So the bond between carbon and fluorine is the strongest bond in nature. And that gives unique properties to the per- and polyfluorinated chemicals. When you have 8 carbons with fluorines around, you have a very stable molecule. PFOA, PFOS are 2 of the names. These molecules have a half-life of 2,000 years. That means if you make a certain amount of this, 4,000 years later, you have 1/4 of it left. Someone at the EPA said about them, these chemicals are toxic, they're everywhere, and they never go away. So you really don't want to make these chemicals unless you really need them, and there aren't safer substitutes. So where are they used? They're used in fast food wrappers, cosmetics, in making Teflon for fry pans, in making Gore-Tex, in clothing like Dockers, in carpet covering, furniture covering. Now the ones with 8 carbons, there's a huge amount of epidemiology, thousands and thousands of papers, and they've been really well studied. Forgetting his name. There's a professor at Stanford, and I'll remember his name in a minute, but he studies these chemicals, and he always walks into class the first day with a white shirt and a bright yellow tie, and he says, "Nice tie, stain-proof, water repellent, but the polar bears are going sterile. Is it worth it?" Because these chemicals go everywhere. They circle the planet. And remember that long half-life, 2,000 years. There's a huge amount of human toxicology for these chemicals because there's communities in West Virginia and southern Ohio where they leaked into the water supplies of hundreds of thousands of people. These people have very high levels. They've done health studies of 40,000 people and found a range of kinds of cancer, thyroid disease, delayed puberty, reduced testosterone, reduced immune response, elevated cholesterol. The most recent one was 5th grade students in the schools had elevated cholesterol in these communities. So there's no doubt of human harm should never be the test for a chemical because we shouldn't be doing experiments on humans. But this is a very sad and inadvertent human experiment on the residents of these communities. So there's a book about this. It's called Stain-Resistant, Non-Stick, Waterproof, and Lethal. It's written by a small-town reporter in one of these communities. And it's really sad. She talks about scientists in the 50s knowing these chemicals, maybe the 60s, the chemicals were harmful, saying workers should never be exposed. The workers not being told, being sort of arm deep in the chemicals, saying, oh, it's just like soap, it's completely safe. And about the community where she lives. So she and her family are part of the people with the high levels. So her name is Callie Lyons. She has a blog, and you can read about her series of newspaper articles about a lot of these findings, which have not made the major media. And in spite of her book and all these human epi studies, one of the young PhDs who works for me wanted to see where the chemicals were, so she went to the Good Guide. If you've ever heard of the Good Guide, they evaluate products. And she discovered they were in cosmetics, which was, waterproof mascara, cream rinse, which was really surprising. And then she looked for toxicity, and the good guide says they raise no health concerns. And so she emailed the good guide and said, well, there's a lot of data on C8. And they said, yes, but we don't actually know what form is in these products, so we really can't say anything. So you kind of have to say we have so much data on the ones we've studied, and then we have others that are perhaps similar, but we don't know as much. So C8 is being phased out. The replacements are C6 and C4. They are similarly persistent. You still have that 2,000-year half-life. They aren't as long-lived in the human body, but levels are going up in our bodies. They're found in groundwater, wastewater, seawater. There isn't much health data known, but they are known to cause cell changes associated with tumors. So outdoor gear, you go into the healthy outdoors, and most outdoor gear, if it's staying in water repellent, it probably now has C6. We don't really know. But if you start thinking about the whole class, you might say, well, maybe this is not the class we want on our products. And maybe that would drive green chemistry innovation, because we ought to be able to come up with replacements that provide these functions without having that carbon-fluorine bond, which seems to be problematic. Okay, class 2 is antimicrobials. They look a lot like dioxins. This is triclosan and triclocarban. There's widespread exposure because they're in personal care products, and they're also persistent. And they're used as disinfectants in hospitals, hand soaps, toothpaste, many places. And it's funny, one of my scientist friends who studies them says, well, if you have gum disease, it might be really good to use an antimicrobial toothpaste. But should young children who maybe eat their toothpaste be exposed to this? And he said, and maybe they're good for surgical scrubs for a surgeon, but we really don't want to kill the bacteria on our hands. It's good to have bacteria on our hands. So it turns out Kaiser does not allow the use of triclosan and triclocarban, which would, because they're concerned about health effects. But yet, there are in most liquid soaps, certain toothpastes. The FDA recently is, I believe, starting to regulate triclosan. So what do? They're endocrine disruptors in the thyroid. They enhance estrogen. They block testosterone. And there are environmental issues. A lot is made. It goes down the drain. Wastewater treatment plants don't really break them down, so they end up in our water supply. They could lead to an increase in resistant bacteria. Again, the question is, do we need them? It turns out it's good to have bacteria on your hands. Getting rid of all the bacteria on your hands is not a great thing. I'm so happy. A biochemist told me that about 10 years ago. He said, don't use antimicrobials. Those bacteria on your hands are the best thing. You want them there. And that was even before I knew about the toxicity issues. But most people don't know that. Right, so do we need them? No proven benefit over soap and water. The food industry researches they're ineffective in flooring and plastic. They don't really help in toothpaste. So there's no evidence they reduce infections. So I think the do we need them is a big question for these. Okay, now that, by the way, this was all Gary Ginsberg's work on the antimicrobials and Jennifer Field's work on the fluorinated chemicals. So flame retardants. So back in the 70s, people, well-meaning, thought we should have flame retardants reduce fires, and they made laws putting flame retardants in kids' pajamas, in furniture, in foam plastic insulation, and nobody, and I shouldn't say putting flame retardants in, they made laws that were best met with flame retardants. So no one ever requires flame retardants, but flammability standards are made, and the way to meet the flammability standards most effectively and economically is with flame retardants. When they made these flammability standards, no one asked, are the flame retardants safe for health? And do these flammability standards actually reduce fires? Do they have a fire safety benefit? And in many cases, as you will see, there is not a fire safety benefit, and there is potentially serious health harm. So I first heard about this back in the 70s. Actually, a friend of mine who was America's leading rock climber, who pioneered environmentally climbing cliffs in Yosemite without using pitons, led people like Yvonne Chouinard and Royal Robbins up the hardest rock climbs in Yosemite free of respect for the environment, died tragically in the Himalayas. And I was very sad, and in his memory wanted to do something to help the environment. And a biochemist named Bruce Ames was on my PhD orals committee. If any of you are scientists, you may have heard of the Ames test. It was a rapid screening test to see if a chemical was likely to cause cancer by seeing if it changed the DNA in bacteria. And so I said to Bruce, what can I do that'll help the environment, help the world, help health? And he said, you should look at the flame retardants in kids' pajamas. And that sounded very peculiar to me, but I said, sure. So it turns out in those days, 10% of the weight of children's pajamas was a flame retardant called brominated tris. And Bruce said, I think it gets into the children. So we found a little girl who'd never worn the pajamas. Her mom bought her pajamas in England. And we had her wear the pajamas. And the next morning, we found tris breakdown products in the little girl's urine. And they were breakdown products that were known to be cancer-causing. And so every child in America pretty much was wearing these pajamas, getting a dose of tris as they slept. Now, when we talked about TSCA, I should say in America, foods, drugs, and pesticides are regulated. We may not be sure how well they're regulated, but things that really go into our mouths are regulated, foods, drugs, and pesticides. But nobody thought that maybe something on your pajamas or in your cosmetics can go into your body the same way. And so we realized these chemicals somehow were getting into this child. So we ran a test to see, did brominated tris change DNA? Was it a mutagen? And it was the strongest mutagen we'd measured. So we wrote a paper, and it was a lead article in Science magazine way back in the 70s, and it was kind of an unusual paper because it made a recommendation. So if those of you read scientific papers, what do most scientific papers recommend at the end as the next thing to do? Always more research. So we had done 2 studies, and we made a recommendation. We said the main flame retardant in children's pajamas is a mutagen and should not be used. That's a pretty strong recommendation. And the title was Flame Retardant Additives as Possible Cancer Hazards. Now, do scientists do that very often? But at the Green Science Policy Institute, this is what we are working with scientists all over the world to do, to take their research and make statements to protect public health. Because when scientists do make statements beyond more research is needed, things happen. And we wrote that paper in January 1977. In April 1977, brominated tris garments were banned by the Consumer Product Safety Commission. So a whole generation of kids only wore those pajamas for a year or 2. However, as we said, when a chemical is banned or regulated, what is the replacement? And what was the replacement for brominated tris? Chlorinated tris. And we ran more mutagenicity screens. It was also a mutagen. We wrote another article in Science. It was removed from kids' pajamas in 1978. However, chlorinated tris from 2005 until about a year and a half ago, when once again they stopped production here in America for furniture, has been the #1 chemical used in furniture and baby products here in America. So does anyone have a couch they bought from IKEA between 2006 and 2010? Okay, so you have chlorinated tris in your couch. Because IKEA really didn't want to use brominated chemicals when one of them got banned, so they moved to chlorinated tris with no idea that it was the same chemical that had been removed from kids' pajamas. They stopped using it when they learned, but there was a period. And probably anybody who bought a couch in that period you're likely to have, 2/3 chance you have chlorinated tris, 1/3 chance you have something called Firemaster 550. There's a small chance you don't have a flame retardant. So why is there a flame retardant in your couch? This has to do with a California flammability standard called Technical Bulletin 117. So if you go home and you pick up the center cushion of your couch, you will probably see a notice like the one on that slide that the article meets the flammability requirements of the California Bureau of Home Furnishings, TB 117. And this was the standard that was, with all well-meaning, passed in the 70s. And this standard has become the standard for all across the US and Canada. And as it turns out, it is not an effective standard. And you can understand that quite easily. The standard says that the foam inside furniture will resist a very small flame for 12 seconds. Now, if you do a thought experiment and drop a candle on your couch, what burns first? The cover. And do you have a small flame or a bigger flame?
Big flame.
You have a bigger flame. And when you have the bigger flame, the fire burns maybe in 1 or 2 or 3 seconds. And when things burn in the presence of many flame retardants, the halogenated flame retardants, you get a lot more soot, smoke, and carbon monoxide. So when you have a fire, soot and smoke obscures escape, and it's the gases, the carbon monoxide, that kill people, not the flames. So for having your couch, and most of your couches are, the foam is about 5% by weight, a chemical like tris, so that means you have a pound or 2 of tris in your home. You get a few seconds delay, but if there's a fire, but then since fires start on fabric, it's a very short delay, and then a lot of toxicity. And indeed, a lot of studies comparing couches with tris, with flame retardants and without, find no real difference in, after a minute or 2, the couch with the tris and the couch without the tris are burning the same, but the couch with the tris has more toxic gases. So what was used before tris? So the chemical lesson here is a chemical called penta-BDE, which sounds like alphabet soup. But I would like to just do a quick chemistry lesson. So if you look at that figure on the top, you see 2 rings, right? Those are called phenyl rings. And because they're 2, that's called a biphenyl. Does that make sense? Biphenyl. And if you put lots of chlorines around it, that's called a polychlorinated biphenyl, PCB. So what do you think about PCBs? Do you want them in your home or your body? No. They're cancer-causing, they're persistent, they're harmful. If instead of having that straight line between the 2 rings, that's a covalent bond, you have that oxygen in this, move down, you have the 2 rings, now you have an oxygen, that's called an ether bond. And if you put bromines all around, you have a polybrominated diphenyl ether. Does that make sense? Now you know what a PBDE is. It isn't alphabet soup. It's polybrominated diphenyl ether. If you have 5 bromines, it's called a pentabrominated diphenyl ether. Okay? And that molecule, pentabrominated diphenyl ether, was used in most of our furniture and other foam products from 1975 to 2004 in foam. It has been globally banned. It's one of only 22 chemicals where 150 countries have agreed to ban it because it is persistent, toxic, and bioaccumulative. If you take your pentabrominated diphenyl, isn't it fun to know chemistry and to know what that alphabet soup is? If you take your, by the way, I love chemistry, I just have to say, when you understand chemistry, you really can solve problems and be healthier. So it's good to learn a little chemistry. In fact, our 6 classes will teach you some chemistry. Okay, so if you have polybrominated diphenyl ether and you burn it, burning is often adding oxygen. So move down 1 figure and you see your diphenyl ether with 2 oxygens. That molecule is a dioxin. Persistent, toxic, harmful. I teach a class at UC Berkeley in the summers on chemistry and public policy sometimes, And I asked one of the chemistry professors, what do you think about students be exposed to this pentabrominated diphenyl ether, the second one down? And they said only in a fume hood wearing full protective gear. Well, couches from 1975 to, anybody have a couch you bought from 1975 to 2004? Well, you're not in California, so it's not for sure. If you're in California, it would for sure have a pound or two of penta. If you're outside California, you've got about a 2/3 chance that it does. If it has a label, it will have the flame retardant. But if we studied 100 couches, 60% of those without the label still had the chemicals. So a label means for sure yes, no label means about a 2/3 chance. So that's the chemical that is in homes from 1975 to 2004. And 98% of the usage of the pentabrominated diphenyl ether was in North America in foam, in part because of Technical Bulletin 117. It has become a global pollutant because these chemicals don't stay with us. They circle the planet. It's really sad. Some of the highest levels are in Arctic indigenous peoples because they tend to go up and come down and then just stick at the North and South Pole. That's why the polar bear had so much fluorinated chemical. So polar bears, things on the Arctic, and people in the Arctic and the Antarctic. And it's really environmental injustice because they're not even using these chemicals, and yet our use of the chemicals ends up in their bodies. So what are the health effects of penta? They're chronic effects. It's not like you get a burn or a rash. You know, people say, oh, I brought my couch home and I felt sick. Well, that's not the flame retardants. They're long-term. Endocrine disruption, neurodevelopmental harm, reproductive harm, immune suppression, and cancer. And for some reason, when there are hearings on flame retardants, there's always someone among the chemical producers saying there's no peer-reviewed science to show any harm from flame retardants. They seem to always say it's not sound science. So we decided to see how many papers there were on penta. So there are more than 4,000 peer-reviewed papers. Some are on analytic techniques, but most of them are around levels going up in wildlife, the environment, animals, and humans. And an interesting thing to notice is the years. Penta was phased out in 2005, and if you look, very few of the papers came before 2005. So it's not even being made anymore. But the research goes on because it stays. The couches stay, it stays in the environment. So when you choose to use these kind of chemicals, you are making a long-term decision for the future. So as I always say, the standard should not be human health studies, but because penta was used for so long in so many homes, there are a number of human epi studies, and they show that the higher the level of penta in women, the longer it takes to get pregnant. During critical windows of brain development, thyroid levels in pregnant women are different in a direction that harms brain development. And there are a number of studies showing, Brenda Ashkenazi at UC Berkeley, Julie Herbstman at Columbia have done studies on IQ. So children whose moms had higher levels of penta during pregnancy have lower birth weight, impaired attention, poorer coordination, and 4 to 6 less IQ points. And when I asked, I said, so how many IQ points do you think the average California child has lost because of penta? And the scientist who did the work said, well, that's really hard to say, but maybe 4, 5 points across the state. Well, when you think of loss of productivity and income, if every child in California is losing 4 IQ points, and probably many across the country. And remember, penta was used to meet TB 117 that didn't even provide a fire safety benefit. So this was a real lose-lose. How do the chemicals come out? You don't have to sit on the couch. They're semi-volatile. That means they're coming out continuously. You know, I've lost track. Do I have till 1 or 1:30? Oh, yay. Okay. I can tell all my favorite stories. Great. Okay. I thought, is it 1? Oh, I'm in trouble. Okay, so they're semi-volatile. They're always coming out. They're going a word called fugacity, which means density. They're going from high fugacity in the couch to low fugacity outside. They want a balance. So if there's a lot in the couch, there's not much outside. They're continually moving out. They're heavy. They drop into dust. And then someone gets some dust on their hands. They eat a sandwich. A child crawls in the dust. Ingestion is the mechanism. About 90% of people's penta is through ingestion of dust. Cats have 10 to 100 times higher levels than humans. Why would cats have 10 to 100 times higher levels? Because of their grooming behavior. And they lick themselves, exactly, the grooming behavior. I mean, people say because they sleep on the couch, but it really isn't. It's not like you sit on the couch or the chair and it goes through your skin. It's because of ingestion of dust. So what about fire safety? As we said, TB117 regulates the filling inside furniture. And the way to meet, it does not say there have to be flame retardants, but the way that it's pretty much always met is by putting flame retardants in the foam, because if you have a piece of bare foam and you want it to not burn for 12 seconds, what can you do but add chemicals? Real fires start on exterior fabric, and indeed most furniture fires start with smoldering cigarettes. Somebody drops a cigarette, it smolders for 20 minutes, the fabric burns through. Electrical sources. A lot of fires now, we have fire-safe cigarettes, so there are fewer cigarette fires. So a lot of fires come from wires, and those are also smoldering fires. So if you can make the fabric smolder-proof, you can prevent the heat from reaching the fuel, which is the foam. And you don't have to add chemical. Adding the chemicals to the foam doesn't do much. Making the fabric smolder-proof really solves the problem. And we talked about fire toxicity. As you remember, flame retardants can delay but don't prevent foam from burning. And so when you have halogenated flame retardants, that means bromine or chlorine bonded to carbon, you will get increased soot, smoke, carbon monoxide, acid gases. And then at the end, remember, penta is one oxygen away from a dioxin. You get quite a lot of dioxins and furans. And indeed, eventually we're going to play a short part of a movie called Toxic Hot Seat, and the heroes are firefighters from the San Francisco Firefighters Cancer Prevention Group. Because firefighters have an epidemic of cancer, and the kinds they have are kinds associated with dioxin exposures. So fires produce dioxins, and flame retardants in particular tend to produce a lot of dioxins. There's no proof that the reason the firefighters have these high incidences is because of the flame retardants, but many of the cancers are ones associated with dioxin exposure. So they know the flame retardants, in many cases, as they're used in many products, don't provide a benefit, and they are concerned that they could be contributing to their cancer. So when we heard about all this information, you know, serious harm, no proven benefit, I remembered back in the 70s where we wrote a paper, and 3 months later, tris was removed from kids' pajamas. And someone said, we'll introduce you to a legislator, Mark Leno, help us, we'll write a bill. And I thought, oh great, 6 months, we'll solve the problem. So that was in 2006. And that's Mark Leno, and there were 4 bills. And they all tried different ways to reduce the use of flame retardants while maintaining or increasing fire safety. And they were supported by scientists, parents, doctors, the furniture industry, the foam industry, the fabric industry, the juvenile products industry. Pretty much everybody supported them. And so why didn't they pass? Sounds like a good idea, right? More fire safety, or at least equal, and stopping this huge, I should say that something like 95% of the people in America have penta in their bodies, which did not help prevent any fires. And we know, we don't know how much, but we know it's contributing to infertility, to neurological impairments, to cancer. You know, you can't say someone has cancer, they have a carcinogen in their body, that's the reason. But across our whole population, adding cancer-causing chemicals to everybody's furniture is increasing these health problems. So anyway, this seemed like a no-brainer. I thought, well, I actually had wanted to move to Kathmandu when my daughter started college, and I thought, okay, I'll postpone my move to Kathmandu for 6 months. We'll solve this problem. And so that was 2006. And in spite of everyone supporting this legislation, it never seemed to pass. Because when our first bill almost passed, this is part of what was a $6 million advertising campaign in a week by Californians for Fire Safety. And who are Californians for Fire Safety? They're Albemarle, Chemtura, and Israel Chemicals Limited, the 3 manufacturers of the flame retardants. And the sad fact about these flame retardants is they are so profitable. There was a press release from Albemarle that their profits had gone up nearly 400% from last year based on their sale of brominated flame retardants. So somebody researched the amount that was spent preventing flame retardant bills in California, and she came up with more than $21 million, which is a lot of money. And she said she thought it was the tip of the iceberg. So it just didn't seem to be working, trying to pass legislation in California. And then everything changed. I sort of joke and say, up until this point, when people at a party would ask me what I would do, I would start to tell them the whole story of the flame retardants, because I wanted them to understand this, it's like the emperor's new clothes. How could this be that every piece of furniture contains these chemicals that are so harmful that don't provide a benefit? And then the people would all move away from me at the party. They'd say, gotta go now. And I thought I would spend my life being, the person everyone moved away from at parties. And then the Chicago Tribune published this series that headline on the front page, I think, says it all. A deceptive campaign by industry brought toxic flame retardants into our homes and into our bodies, and the chemicals don't even work as promised. So this, and if you haven't read it, Google Flame Retardant Tribune or Playing with Fire. It's a story of deception and drama, and it came in second for the Pulitzer and won that whole slew of investigative and environmental reporting awards. They ultimately had 20 front-page stories about flame retardants that year. And then instead of meeting the person who was going on and on about flame retardants, suddenly Dick Durbin and Barbara Boxer were, and there were hearings in the Senate, and everything changed. And shortly after the Tribune came out, Jerry Brown directed the state agency responsible for the standard to reevaluate the benefit of the open flame standard, and they came up with a smolder standard for fabric. That's where fires start. And by making fabric smolder-proof, you can just stop the fires before they reach the fuel source, which is the foam. So you can actually increase fire safety, and you can do it without flame retardants. So this was a big deal. And also they exempted all these baby products. So it used to be nursing pillows, high chairs, strollers, all that foam had flame retardants. Well, those are not places where fires start. You don't want your brand new baby to be exposed through their baby positioner. So none of these products are required to have flame retardants. They won't have labels. We're in kind of a messy transition, but within a few months, all these products should be flame retardant free. And so the status of the new standard, it's called Technical Bulletin 117-2013. It was implemented on January 1st, last January. It's going to be mandatory next January. And so you should look for a label. If you're going to buy furniture, look for a label with the new standard, and then ask if there are flame retardants present. Flame retardants are not needed to meet the standard, but they still can be used. And as we hear it, most manufacturers are removing the flame retardants, but there is a big pushback in many directions to keep the flame retardants in. So it's, we'll see what happens. As I said, we're in kind of a messy transition right now, but if you want to buy furniture, just ask for furniture without flame retardants. 85% of fabrics already passed the new standard. If your chair is leather or a heavy synthetic, it's smolder proof already, so it's protected. You're not going to have smoldering go through to the foam. 15%, like cotton, are not smolder proof. So if you have cotton fabric, like IKEA, a lot of their fabric, they have to have a batting barrier between the fabric and the foam to protect the fuel. So part of what's happening now is public information, and I think now, to take a break from all this talking, there was a movie made called Toxic Hot Seat all about this. And I think if there's someone here who knows how to make why don't we take our little break now?
Everyone has a fear of fire, right? No one wants to burn up in a fire.
The temperature rises and rises until suddenly everything is burning.
We have developed a method for applying a flame retardant in the home.
Every American home has flame retardants in their couch. These are chemicals measured by pounds and ounces.
Flame retardants accumulate in people and wildlife in places around the world.
And they're toxic and building up in breast milk and being passed on to the next generation. We are in the middle of a giant, uncontrolled experiment on American children.
Why do we have these chemicals in our lives? Why do we have them in our furniture? Why do we have them in our bodies?
Flame retardants are important to save lives.
We already have the highest fire safety standard.
The study is so obscure, we had it translated in English. The industry doesn't have a copy. You can't find it online. We had to go to the National Library of Sweden to get a copy.
If the science shows these chemicals don't really even work, why are we getting the potential risk and none of the benefit?
These fires now are just an absolute toxic soup. I had transitional cell carcinoma, a rare form of cancer found in people in the chemical industry.
I've had coworkers die in fires, and I've had a lot more die of cancer.
I had all these chemicals in my body, including flame retardants. Folks said we need a legislator willing to take on a fight against the chemical industry. And I was like, let's go for it.
Health advocates and the chemical industry are facing off in Washington.
I had no clue what kind of opposition we were going to be facing.
There was a campaign of marketing and deception.
We've brought the signatures of 130,000 Americans with us.
Regular people stood up and said, look, we don't want to take it anymore.
You don't let the fire win. We win.
Who are we listening to when we're being told these chemicals are safe, they work, they protect us, they are essential to our lives? Who are we listening to?
Anyway, that's on HBO. Unfortunately, it's not on Netflix, but if you have HBO Go, you can see it. If you want to, let's see, and you can Google toxic hot seat. Though if you Google it, the first entry that comes up is the American Chemical Council, and then the second one that comes up is the film. So go for the second one. Anyway, so the word's coming out. It's a bit dramatic, but Jamie Redford made the film and really does focus on the firefighter story. And actually, after I saw the film, I decided I wanted to write a book. I don't think I have time, but it's so interesting, the characters in this world of flame retardants. So. Okay, so let's just see. Let's find a... So one question is, now we have turned off the tap. New couches, presumably in the next months, will not have flame retardants. So what's going to happen to all that flame-retarded foam and those toxic couches? There are tens of millions in this country. And the most natural thing is people who can afford it will buy new safe couches, and then the toxic couches will go to low-income communities, student housing. We've heard the average couch has 2 to 3 owners of 10 to 15 years each, which means the toxic furniture will be in low-income communities for decades to come. So if it's not resold, then it's landfilled, and there's data that the flame retardants leach out of landfills. They end up in water, soil, and they end up in the food supply. So right now we get about 90% of our flame retardant dose from our dust, ingestion in our homes, and about 10% from food. And there's data a paper predicting that as time goes on, we'll get more and more from our food. But that's not really what we want. We want to do something with these toxic couches. So the third thing that's done right now is the foam from the couches is, quote, recycled. It's chopped up into carpet cushion. So the toxicity goes from the couch to the carpet. So do any of these look like good things to do? I don't know which one is worst. So we have a project on better solutions. And we have just started a foam exchange at 5 foam stores in the Bay Area. It's launching May 1st, when there's going to be safer foam available in all grades, where people can swap out the cushion foam. So it turns out that couches that aren't very expensive have foam just in the cushions. In the backs and the sides, they have polyester, which is not treated with flame retardants. So if you swap out your cushion foam and get safe foam, in many cases you've dealt with 100% of the problem, or in a high-end couch, about 85%. There's still foam in the backs and arms, which could be swapped out with reupholstery, but that's expensive. But just changing out, if many, many people swap out the toxic foam for safe foam, that means when their couch goes to a low-income community or a landfill, it's not going to be a source of toxicity. So we're piloting this in the Bay Area. We're hoping that people will do this around the country. But then the next question is, what do you do with the toxic cushions? And I should say one of our young PhDs, a really brilliant guy from UCSF, has been working on this for the last 6 months. And it's complex, but there are 3 kinds of solutions. One is chemical recycling, and you can break apart the foam and melt it down and make new foam. There's a business in Detroit that takes car foam, breaks it down, and makes new car foam. The only problem with that business is when you look on their website, they say the foam is flame retardant enhanced. So that's not what they want. They don't separate out the flame retardants, but it is a for-profit business. But we've located a manufacturer in Canada who has a process where he can break down the foam, precipitate out a mush of flame retardants, and make new foam. And we're just working with, I think, he says he can, and we're working to verify this. So it might be possible to take the foam, separate out the flame retardants, make new foam, and make that break even, because the foam is of value. So you go, originally when I thought about, 80 million couches with toxic foam, what do you do with them? I used to have a joke slide say put them in Yucca Mountain, but it would overfill Yucca Mountain. But if instead of that you think about the cushions, and then if it's really just a pound or 2 of flame retardant to deal with, that's a much smaller problem. So that's one, and this is something that research is needed. People who join our foam exchange, all the foam stores are contributing a share of the proceeds to research on what to do with the toxic chemicals. And in the past, they would have just given the foam to be chopped up into carpet cushion, but they're saving the foam, and we're going to be using it for research. Energy recovery is something that people don't like the idea a lot, but there are many kinds of energy recovery. And Stephen in our group is working on if there are processes, and then more secure landfills. But at least if you ask the question, instead of just, because right now the couches, they'll just end up in low-income communities or landfills. And so we're hoping to do something better. But again, when you create molecules that are very persistent and toxic, you have a big problem. And you want to think carefully before you create these molecules. Are they necessary? Do we need them? Could there be a green chemistry solution or another technical solution? It shouldn't always be just a drop-in chemical. Maybe there's a different way to make or design products so that we can have the functionality we need without a potential for toxicity. So let's talk about buildings, which is what we're here. And plastic foam insulations that make buildings energy efficient that we need for global climate change are polystyrene, polyurethane, and polyisocyanurate. And they're used increasingly for energy efficiency inside walls, below grades, and attics. In California, our building codes are that walls have to be twice as wide, so there'll be twice as much of foam in the walls. We're increasing energy efficiency. Right now, all three of these materials are treated with halogenated flame retardants. That's the class that when it burns produces dioxins. And so far, when they've been studied, none of the halogenated flame retardants have been found to be safe for human health. So all polystyrene, XPS and EPS, is currently treated with a chemical called hexabromocyclododecane, more alphabet soup, HBCD. And it's bioaccumulative. It causes thyroid disruption, affects the developing nervous system, and it has been listed, it's number 23 of the chemicals banned in 150 countries under the Stockholm Convention. And again, I don't know that workers who are dealing with EPS and XPS have been told anything about this. So it is being phased out. The chemical used with polyurethane and polyisocyanurate is a form of tris. It's TCPP. It's related to the tris in kids' pajamas. It's a different one. It's known to accumulate in liver and kidneys and affect nervous system development. It may or may not be cancer-causing. There are 3 forms of tris, very closely related. The other 2 are known to be cancer-causing. This one is being studied at the National Toxicology Project. However, all of these are halogenated flame retardants, so they all share the quality. When they burn, they produce dioxins. So as I said, HBCD is being phased out, and the replacement is Emerald 3000. Sounds green. What is Emerald 3000? Well, you take styrene, which is cancer-causing, you take butadiene, which is cancer-causing, you make a big polymer, and you put bromine in. Now, it's a polymer, so polymers are not as, during use, there should not be a health problem with a polymer. Polymers are big molecules, they stay together. In use, there should not be a problem. However, the life cycle, and I don't know how right these numbers are, but I think about 30 million pounds a year of flame retardants was used in furniture, and it's about 130 million in insulation and growing. So producing 130 million pounds of a chemical consisting of harmful chemicals that could at some point break down, you want to ask, is this necessary? Does it provide a benefit? And when you look at the life cycle, there are problems during manufacture, worker exposure of the flame retardants, of the product. During the consumer use, hopefully there are no monomers. Do you know mono is one, poly is many. So when you have one molecule, like vinyl chloride is highly carcinogenic, but you put it into polyvinyl chloride, and actually while it's in the polymer, it shouldn't be a problem. Now, PVC is a problem because it's mixed with lead and phthalates, but polymers themselves don't harm, it's a big molecule, but you have to look across the whole life cycle. So during flame retardant manufacture and product manufacture, there would be worker exposure. There could be chemicals going into the environment. Disposal, about 80 to 90% of the HBCD exposure is during disposal. And HBCD is found all over the planet, in wildlife, in dust, it's everywhere. And again, fire incidents on the far right, when it burns, you get dioxins. And that is a problem for fire service and emergency responders. So even though consumer use is better across the whole life cycle, you have to ask, do we really need it? Is there a fire safety benefit? And in the case of these foam plastic insulations, there is not, in most uses, a fire safety benefit. So most places where you have these foam plastic insulations, you have a thermal barrier separating the plastic from inhabited areas. The thermal barrier has to withstand flashover ignition for 15 minutes. So by the time a fire burns for 15 minutes at flashover, through the thermal barrier, the sheetrock wall, and it hits the foam with a little flame retardants, what do the flame retardants do? They make more dioxins for the firefighters. Also, the test that's used to measure flame spread is something called the Steiner tunnel test. And there have been many papers saying that it is an ineffective test. You mount a little bit of the material up high in a tunnel with a flame, and these foam plastic insulations just drip onto the floor, and they can't even be measured. So the thing in the building codes, it calls for the Steiner tunnel test or E84. To meet it, you add flame retardants, but it's a bad test. There's no relationship between how something does in the Steiner tunnel test and real measures of flame retardant. So it's not, you have a not accurate test, and also the thing that matters is the thermal barrier. Foam does burn, you want it behind a thermal barrier. Adding the flame retardants does not make much difference, but adds toxicity to the world. So the question is, should building codes be changed? For example, between the slab and the soil. Is there a fire hazard between the slab and the soil? No. But the chemicals can just leach out and go into water and soil. Or below grade, if you look at the picture where you're down. In other words, if the insulation is only, it's in concrete construction. Sometimes your insulation is completely surrounded by concrete or concrete and soil. So if you have insulation below grade or behind a thermal barrier, do the flame, there's not even a possibility of a fire, or in buildings with automatic sprinklers. So the question is, can codes be changed in these uses so these insulation materials can safely be used without flame retardants? And there have been code change efforts. The 2015 International Residential Code, there was a very good effort, and we wrote what we do is write scientific papers. We wrote a peer-reviewed paper pointing out the lack of fire safety benefit and the harm. If you want to know more, go to Green Science Policy website and click on Safer Buildings or something like that, and you can find a peer-reviewed paper reviewing the detailed scientific research showing the lack of benefit of the flame retardants and the health harm. Right now, there's the International Green Construction Code, and there are code change proposals that are submitted. And in California, I was just astonished. One of the legislators in California said, California will take the lead. We will change our building code so when there's no fire benefit, flame retardants won't be needed in insulation. And I said, legislation never passes in California, but it actually did. But then it turned out to be problematic. So anyway, around the International Green Building Code proposals, you can see more information at saferinsulation.org. There are 3 proposals around disclosure, surface burning characteristics, and around halogenated flame retardants. And if any of you live in Memphis or near Memphis, David Eisenberg is leading this project, and he would love to have people come and testify. And then there'll also be a hearing in Orlando. Well, I don't see the Orlando one. Anyway. So the way these hearings work is everybody who's there gets 2 minutes to testify. So at a hearing on the International Residential Code, I think there were just 2 or 3 people testifying that there was not a benefit from the standard leading to the chemicals, and then many people testifying that we had to have the chemicals. And so David appreciates, so there's his email, strawnet@gmail.com. Many of you might know David. He helped found the first code committee for the US Green Building Council. So if anyone's in Memphis, and then there's a hearing in Orlando later on, and so contact David. And so right now in California, we do have legislation that has asked our state fire marshal to propose new standards to maintain fire safety, but give a choice in meeting the standards with or without the use of flame retardants. But the process is not going well. The process is anyone who has a lot of time to work on this is part of a working group. And unfortunately, the people who have a lot of time tend to be people who are paid by industry. So we will see what happens. Okay, well, I'm a little ahead of time, which is unusual, but we can have questions and discussions. So this is our team at Green Science Policy. We have 5 PhD chemists, 2 masters in public health, and we are trying to work with scientists all over the world to help craft research that leads to public policy and changing our policies to protect health and safer chemicals. So I'd be happy to answer any questions. Thank you. Does anyone have questions? Yes.
So I'm manning the online portion of this. So from the chat online, Greg Berkhold asks, has there been any data that shows leaching of FR into soil from XPS foams? Sorry, I have to keep over.
And I know Greg well. He's from Dow. We've had a number of conversations because we want Dow. By the way, we think the foam industry should support this because we think it will increase their market share. That green builders are choosing not to use foam insulation to avoid flame retardants, and if there's a choice to have insulation with or without flame retardants, it will become less expensive, healthier, and will give more options. So I'll say hi to Greg, who's listening. And the answer is that research is needed. But we do know that about 90% of the HBCD made is used in insulation, and it is found everywhere. And there is research that it's mostly when the buildings are taken down is when it gets into the environment. During use, we really don't know. I know the environmental engineering professor at Berkeley who studies this says buildings are not perfect envelopes and they have light switches, and of course some is getting out. But I don't think this has been shown. It's hard experiments. When Paul Anastas was the head of research at the EPA, I was like, couldn't you please do those studies? And Paul said, it's a waste of money to do the studies. You should just not be using those kind of chemicals in your buildings. It doesn't matter. So anyway, that was Paul Anastas' answer. But I've been trying to encourage Lawrence Berkeley Lab. I think it's really important to do the studies, and maybe Dow could help sponsor some of the studies. They might have the resources to do that. I think those studies need to be done. Other questions? Yes.
I have a question. You have to forgive me, I'm not a chemist, but this may be a dumb question. I'm an architect, and a product that's used often in insulation is a cellulose product that's blown in, but it's borate treated. Does that product fall into this category, or a product like that?
No. Borates, you don't want to eat borates. They're teratogens, but they're not semi-volatile, so they're not coming out. The life cycle isn't such a problem. I mean, I'm not an expert, I will say that, and they are on some lists. So I guess we all know the most about what we work on, but they, to me, okay, my inexpert, I'm not an expert, but they're not persistent, bioaccumulative, and toxic like a lot of the other flame retardants are. But they do have some toxicity, but they're not always coming out. Yes?
Can you talk about some of the materials that are used for insulation that do meet code that don't use flame retardant chemicals?
Well, there are a lot of them. For example, back when I started doing this, somebody was making the greenest visitor center ever in Yosemite, and they were going to cover it in polystyrene and HBCD, and they heard and they changed to rock wool. And there are a number of materials like that. But for a number of years, we talked about alternatives, and then I came to realize that only some people can afford the alternatives. It's just like organic. Some people can afford an organic couch. I mean, I guess I didn't have that slide, but like I had one of the highest levels in penta in my dust, and I got rid of my couch. I didn't have a couch, and my daughter couldn't bring her friends home, and then someone gave me an organic couch, but I could have never afforded one. So the problem, and maybe someday organic couches would become affordable, but it's a lot better to change the code so regular materials don't need unnecessary flame retardants. So the answer is there are alternative materials for those who can afford them, but if the only reason we're putting these harmful chemicals in our insulation is because of a flammability standard that does not provide a benefit, maybe we should just not add the chemicals. So anyway, so I'm more focused on changing codes than on alternative materials right now, because the code, I think, and even that visitor center in Yosemite, between the slab and the soil, he said he had to use polystyrene. There was not an alternative for that. And that's a place where there's no fire hazard and the chemicals are going to be coming out. So I forgot to say that if anybody is interested in this, please go to our website and join our e-list. We send out a message once a month about flame retardants policy, and or give me your card, or we have some sign-up sheets as you go out for people who are here. So we just send one email a month, and if you don't like it, we're happy to have you not be on our list. That's right. And then my last pretty mountain slide. I am really optimistic that around flame retardants, the good news is we can have equal or greater fire safety in many, not in all cases, but in a number of important cases without using them. So this seems like a potential win-win. So other questions? Yes?
I have a quick question. Recently, we've seen the new bio-based plastics, PLA, those types of things. What's your thought about them in terms of being a safer product in general?
You know, I'm not an expert on it, but you have to really make sure that what you're moving to is safer, because, you know, there's this whole outcry about BPA, and you see these bottles that say BPA free, and one of my toxicologist friends, who likes to be a little bit outrageous, said, well, if I need a plastic bottle, I look for one that has BPA in it, and I look shocked. And he said, yeah, because it's so much better than BPS, which is the substitute. So if it says BPA free, you have BPS. And so you really have to know what the alternative is, and that's what goes back to the 6 classes. Because for certain functionalities, if you avoid whole classes that when every member of the class you've studied has a harm, maybe you avoid that. So you don't go from BPA to BPS. You rethink the process. And often, again, it's not a drop-in chemical. It's, do we actually need this functionality, and is there another way of achieving the functionality without drop-in chemicals? So I'm not an expert on plastic, but the question, and in fact, when we did our series, our final lecture on green chemistry was this beautiful lecture about biomimicry and all, and I said, no, I just want some specifics. Everybody in this series says, we want specific substitutes. Do you have specifics? And the speaker said, well, you know, we haven't really proven that the specifics are safer. So you have to know that just switching out of something harmful does not, you know, brominated tris to chlorinated tris, penta back to chlorinated tris. You know, it doesn't necessarily get you anything. You have to evaluate what you're getting into. Yes?
Is there a place where you can go to figure out the difference between the marketing name and the chemical name and what it means? Because it can be so hard to try and figure out, even if you go and read the MSDS sheet, you go to section 15, which I unfortunately read a lot, it's very hard to kind of pick those things out. You know, I'm an architect. I didn't get any chemistry in college. I got a lot of physics. I'll tell you how to make the building stand. But the chemistry of stuff, I don't know. And then you deal with all these marketing names, these brand names, and you know.
Yeah, that's what I think LEAD 4 is trying to have more disclosure, because frankly, even if you are a chemist, there's no way to find out. It's often not disclosed, and that makes it virtually impossible. So not sure how we do it, but the product manufacturers need to disclose what's in their products, and they often don't know. You know, somebody who some young people came to me who said they were making this wonderful non-toxic firefighting foam, and could I please certify that it was non-toxic, and I said, sure, but I need to know what's in it. And I won't even go into it. We spent like 6 months, and finally we had to sign a non-disclosure and learned what was in it, but they really didn't know. They could not find out. So that is a huge, huge problem. And I'm not sure I know, does anyone in the audience have thoughts on how to solve that? I know the USGBC is trying to solve that. So, yes?
I guess all I would add to that is that we are trying to use CAS numbers as a standard way to communicate specific chemical compounds, not by trade name or chemical name, but by CAS number. So sometimes that helps.
Yeah, so transparency is very, very important. And we're not there yet. Okay, well, I think there are no more questions. Okay, well, thank you very much. I hope some of you will sign our mailing list.